Okay, so what is a derivative? So derivative is measuring change. So specifically, it's the instantaneous rate of change at a point. So I'll graph an equation here, and we'll just ignore what this equation is for now. But let's say I want to find the derivative of this point. What the derivative is it's the instantaneous rate of change at that point, which is essentially just imagine a line that's tangent to here, to that point. It's telling us essentially what the slope is of that line at that point. So it's telling you how much this original equation changes at that point. So if we looked over here and we're like at this point over here, what is happening? So at this point we know it's going down. So it's going to be a negative. The derivative at that point is going to be negative, and it's going to be pretty steep because it's going down pretty fast, but it's just measuring the slope of that line that's tangent to that point. And then in real life, if you want to think of the derivatives, if you take, in real life, your speedometer in your car kind of acts like the derivative of your position. So when you're driving, say you're in a car, so here's a car, it's not that good of a drawing, you're moving this way, your speedometer is essentially getting your derivative of your position. So if you take the derivative of your position, derivative of your position is equal to your velocity. So if you think of it like as your position changes over time, that's essentially just the same thing as saying your speed or velocity. And then if you take the derivative of velocity, you get your acceleration. Which is just how your speed changes at certain points on the graph. So if we have a graph, and say this is time, the x-axis is time, and then this is, we'll say this is your speed for the y-axis, and then we'll make some graph. So this is here. So if you want to interpret this as this is the speed you're going, this is just time. So this origin would be, this is the start, and then this is your takeoff. And then right here you can tell that you really push the gas and you start going really fast. And then right here you peak, and this is actually called a max. This would be the maximum because this looks like I drew it slightly higher than over there. This is the maximum, and you're at this maximum for just a second, and then you slow down and you come back up, and this is just where you kind of flattens out at, and this is a constant speed here at the end. So what you can think of is this shows your, if you took the derivative of this equation, you'd be able to find your acceleration at certain points. So we can introduce some of the basic derivative rules. So we have the constant rule, which the derivative of a constant is always equal to 0. So if you see no x or no variable in general in an equation, it's always going to be 0. So if you're taking the derivative of a constant, so let's say you're taking the derivative of 10, the derivative is going to be 0. If there's no x in the equation, it doesn't matter if that's 10, or if this is 1,000, if it's any weird number, it's always going to be 0 because there's no variable in there and there's no change. Now, for the next one, you actually have to do a little bit more thinking than that. It's called the power rule. You take the derivative of something that has a power. So we'll say there's x, n is the power, so it's to the power of n. And then what you have to do to find the derivative of it, you have to take x to the n minus 1, and then n out front is how you find the derivative of it. So if we have 7x squared, and we want to find the derivative of it, what you want to do is you take the 2 and you multiply it by the 7, so we get 14, and then from this we have the minus 1, and it's just 14x is the derivative of 7x squared. And these two are really the easiest derivative rules to remember, to be able to go through and do the process of. So if we take the derivative of, we're going to do 8x to the 5th, we get 8. We have to multiply 8 times 5, which we get, that is 40. 40x, and then we just subtract 1 from there, and it's 40x to the 4th. So let's say we want to take the derivative of something. Let's take the derivative of x squared. So let's say this is 1, 2, 3, 4, and this is like have to be a little bit larger values, but so it kind of just goes up like this. So let's say this graph isn't exactly the best, but okay, we'll just say this is x squared. If we take the derivative of this, so the derivative of x squared, we put the 2 out front, and then we subtract 1 from the original power, which would just be 1, so we'll just leave it at 2x. So the derivative of this is 2x, which we know because if this was 2, then we know this value here would be 4 at that point. So if we wanted to find the derivative on this equation at point, let's say x equals, we could really do anything at x equals 6. We know that the change at that point would be 12 using the derivative, which is equal to 2x.